All right, so we just went over a few examples where we solved an equation by creating a system and graphing the system. We use the intersection points to help us identify our solutions to the equation. So you also can do some algebra to help you find a solution to a system. So here we have two systems. We're going to look at this one on the left first. I am going to go ahead and put a bracket around it because to me that just kind of keeps it together as a nice little system. You guys have not solved systems of equations using substitution in a long time. So let me remind you of how that works. When you do substitution, you would like one of your equations to have been solved for x or solved for y. So see how this one was y equals this, and this one is y equals this. So the way that we do substitution is we recognize, I'm going to just go to the bottom one. If y is equal to a 2x minus 4, that means I can take that and substitute it in to the y of the other equation. Now I can rewrite the equation. 2x minus 4 equals x squared minus 6x plus 8. Now we want to solve for x. We have 5 ways that we have learned in this unit how to do this, how to solve the system. One is by graphing. We're not going to do that. So I guess we have 4 algebraic ways. Let's see if we can factor it. That's always my start because if we can factor it, we're done quickly. We'll get everything to one side, so our equation is set equal to 0. And whichever side has the positive x squared, that's the side I want all the terms on. So I'm gonna do a couple steps at the same time. I'm gonna subtract a 2x. I'll come over here and subtract a 2x from its like term. And I'm gonna add 4, and I will add 4 to its like term. When I rewrite the equation, 2x minus 2x cancels, negative 4 plus 4 cancels. So we have 0 equals x squared. Negative 6x minus 2x is minus 8x, and 8 plus 4 is plus 12. So, can we factor this? Are there factors of 12 that add up to a negative 8? And if we think through our factors, 1 and 12, 2 and 6, 3 and 4, it's the 2 and the 6 that we need, and we want them both to be negative. If they're both negative, they multiply to 12, and they will add up to a negative 8. So we're going to say 0 equals x minus 2 times x minus 6. When you have factored form set equal to 0, to solve, we just set each factor equal to 0 and solve these pretty basic equations. We're going to add 2 to both sides, add 6 to both sides. So we have x equals 2 and x equals 6. Now I need to point something out. We are solving a system in this example. The original problem has x's and y's in it. X's and y's. So I just found 2 x's. I do need the y's that go with these x's. So our answers are going to be ordered pairs. That is not what the solution was in the last example. So we need to keep this straight. If the original problem has x's and y's, then your answers are ordered pairs. If the original problem is an equation with just x's, then you only want the x coordinates as your answer. Okay, so we are going to take a 2. We can plug it into either equation. We'll get the same answer. So I'm going to pick the easier equation. We know that y is equal to 2 times 2 minus 4. 2 times 2 is 4, and 4 minus 4 is 0. So when x is a 2, y is a 0, so there is one of our solutions, 2, 0. Now I'm going to take that 6 and just plug it into the same equation. Y equals 2 times 6 minus 4. 2 times 6 is 12, and 12 minus 4 is 8. So when x is a 6, y is an 8, and there's the other solution to the system. All right, let's run through another example. We will go ahead and put our bracket, because for some reason that was not on the system, which is okay. They're telling us it's a system, but I just like them to look consistent. All right, they're both y equals, so I'm just going to pick one, y equals x squared minus 2. I'm going to substitute it in for the y of the other equation, and then we're going to write our new equation, x squared minus 2 equals negative x plus 4. Let's go ahead and get all your terms to the side where x squared is positive. So I'm going to add x to both sides. It does not have a like term. I'll just kind of put it in the middle here. We're going to subtract 4. So on the left side, we have x squared plus x, and negative 2 minus 4 is minus 6 equals, these x's canceled, the 4's canceled, so that's how we're left with a 0 over there. So we always try to factor first. Are there factors of negative 6 that add up to a positive 1? So the factor pair we're looking for is a 2 and a 3. And if we make the 2 negative, negative 2 times 3 is negative 6. Check. Negative 2 plus 3 is equal to a positive 1. So we're meeting both criteria we need in order to factor this. So factored form, x minus 2 times x plus 3 equals 0. Now we use our zero product property and we set each factor pair, or each factor, equal to 0. Let's go ahead and solve. We'll add 2, we'll subtract 3. So one of our values for x is a positive 2, and the other one is a negative 3. Now again, because the original problem had x's and y's, I need x's and y's in the answer, so I want ordered pairs. We are going to take this 2, we can plug it back into the top equation or the bottom equation. Let's see, whatever one seems easier. Maybe I'll just go with the bottom one again. They both look pretty easy, so it really doesn't matter. So y equals x squared minus 2. So I'm going to plug in a 2 for the x. 2 squared is 4. 4 minus 2 is 2. So when x is a 2, our y value is a 2. So there's one of our solutions to the system. Now I'm going to plug in a negative 3. Y equals negative 3 squared minus 2. Negative 3 squared is a positive 9. And 9 minus 2 is 7. So y equals 7 when x is a negative 3. So our other solution is negative 3 for the x, positive 7 for the y.